Good morning, this is Kavi Priya, Assistant Professor, EC Department. I am going to deliver about the topic quadrature phase shift keying. So, generally, a phase shift key, in case of phase shift keying, the phase of a carrier is varied to represent two or more different signal elements. Both peak amplitude and frequency remains constant. In binary PSK, we have only two signal elements, one with 0 degree phase shift and other with 180 degree phase shift. Whereas in case of bandwidth of binary PSK is less susceptible to noise than ASK. PSK is superior to ASK because we don't need to have two carrier signals. We have two carrier signal in case of FSK, whereas in case of this PSK it is not required. And also the implementation of BPSK is easier. The signal implement with phase 180 degree can be seen as a complement of signal with a 0 degree phase shift. And this phase shift keying is a method of digital communication in which a phase of a transmitted signal is varied to convey the information. There are several methods that can be used to accomplish this PSK. A digital modulation scheme that conveys data by changing the phase of the carrier wave. It can either determine the A digital modulation scheme that conveys the data by changing the phase of the carrier. It can either determine the absolute phase relative to the unmodulated carrier or reference signal or change in the phase. So number of different phases uses determines the amount of data that can be transmitted in each cycle. So this is the binary phase shift keying implementation diagram. Here the signal will be having a 0 degree phase shift when 0 is being get transmitted, and it has a 180 degree phase shift when a signal 1 is being get transmitted. So the carrier will undergo a 0 degree phase shift when digital data is 0, and the carrier will undergo a 180 degree phase shift when digital data is 1. So in case of QPSK, to increase the bit rate, we can code two or more bits onto a single element, single signal element. In QPSK, we parallelize the bit stream so that every two incoming bits are split up, and a PSK a carrier frequency. One carrier frequency is phase shifted 90 degree from the other in quadrature. So the two PSK signals are then added to produce one of four signal elements. So this is a QSK diagram and its implement and its model graph. So in the case of this QPSK, we'll be having a 2 to 1 converter, and we'll be having a one oscillator, and we'll be having a multiplier circuits and summing circuit. So this input signal will be given to the mixer, and other input is the oscillator, and both is being get added in case of the added circuit. So in case of QPSK, we'll be having a 4 phase shift here: 0, 90, 270 and 360. And this is the 3 consolation diagram for a QPSK. So first one is a ASK. We call it as an open keying, on off keying, and second one is a BPSK, and third one is a QPSK. So QPSK will be having a 4 phase shift will be there. And what are all the advantages of this QPSK? It allows the data to be carried along a radio communication signal much more efficiently than with the frequency shift keying. And quadrature phase shift keying is another form of data transport where 4 phase states are used, all within 90 degrees of one another. So we'll be having a 4 phase shift here: 0, 90, 180 and 270 degree. So all will be of a 90 degree of one another. Drawback is that it is non-coherent reference signal. It produces more incorrect modulation because the error can integrate with the time, since a reference signal for demodulation is not fixed. So here in case of all the ASK, FSK and BPSK techniques, we'll be having a threshold value which is taken as a reference. Whereas in case of QPSK, there is no reference value, so that the error signal will also get integrate, so it results in more error signals. So the demodulation may results in incorrect value because of the absence of the reference signal. Applications. So this it is used in the quadrature phase shift keying is used in the optical communication. It is used in local oscillator. It is used in delay and add demodulator, and it is used in the nonlinear effects for WDM transmission, and it is used in multi-channel WDM. So that's all about the introduction to the phase shift keying and introduction to the binary phase shift keying, and we have seen what is this quadrature phase shift keying and what is the diagram for generating the quadrature phase shift keyings, and we have seen what are all the advantages of this quadrature phase shift keying and what are all the drawbacks, and finally we have seen what are all the applications of the quadrature phase shift keying. So in case of quadrature phase shift keying, there will be a 4 phase shift, whereas in case of the in binary phase shift keying, there will be only a 2 phase shift. It is nothing but 0 and 180 degree. Whereas in case of QPSK, there will be a 4 phase shifts. So that's why we call it as a quadrature phase shift keying. Thank you.